This is part 21 of Entity Framework tutorial. In this video, we'll discuss implementing table per type inheritance with code first approach. This is continuation to part 20. In part 20, we discussed implementing table per type inheritance with database first approach. In this video, we will be modifying the example that we worked with in part 20. So please watch part 20 before proceeding. By default, Entity Framework creates one table for all the entity types in the inheritance hierarchy. Here we have got three classes: employee, permanent employee, and contract employee. Permanent employee and contract employee classes are inheriting from the employee class. Now by default, Entity Framework is going to generate one employees table, as you can see here, for all these three entity types in this inheritance hierarchy. Let's look at this in action. Let's flip to Visual Studio. So this is the example that we worked with in the previous video session. We have generated this employee model from our sample database using database first approach. So let's go ahead and delete this employee model. And let's also delete the connection string that's auto-generated for us from the web.config file. Webform1.aspx and its code behind file are not going to change in any way. So to this project, let's add a class file and let's call it employee.cs. And this class is going to contain the properties that we have seen on the slide, that is ID, first name, last name, gender. To speed things up, I already have typed the required code, so let's copy and paste these properties within the employee class. And similarly, let's add another class file and let's call this permanent employee.cs. And this class is going to contain annual salary property, which is specific to permanent employee. All the other properties this permanent employee class need are going to be inherited from the employee base class. Similarly, let's add another class file and let's call this contract employee.cs. And this class is also going to inherit from employee class, and here we are going to have the properties that are specific to contract employee, which are hours worked and hourly pay. So let's go ahead and include those properties here. And we need another class file, and let's call this employee db context. And here we need system.data.entity namespace, so let's bring that in. And we want to make this employee db context class inherit from db context class. And this class is going to contain a public property which is going to return db set of employee objects, and let's call this property employees. Alright, and we need to have a connection string within the web.config file, and here is the connection string. So the name of the connection string is going to be employee db context. That's the connection string, and the provider name is system.data.sql client because we are using SQL Server. Alright, so with these changes, if we now run this webform1.aspx, so at the moment we already have the sample database, so let's actually go ahead and delete this sample database. So now when we run this project, it should automatically create the sample database. And by default, if you look at the types we have, there are three types in the inheritance hierarchy. But by default, Entity Framework is going to create one table to store the data of all these three entity types. So let's actually run that and prove it. So webform1 is being loaded. So at this point, sample database, when we select this all employees radio button, the sample database should be automatically created, and then the employees table also should be created. So it's still trying to load, and it's completed. Now let's actually refresh this databases folder, and if you look at the sample database, notice that we have got the employees table. There's only one employees table, and if you look at all the columns, look at that, the properties of the employee class are present first, which is employee ID, first name, last name, gender, and then we have the columns of contract employee class. So contract employee class has got hours worked and hourly pay properties, so we have those columns here. And then we have annual salary property within permanent employee class, which is again a column here. So all of the columns are now present in this one employees table. So that's the default behavior within entity framework. But our requirement is we want one table to be generated per entity type in the inheritance hierarchy, meaning we need one employees table for employee type, similarly permanent employees table for permanent employee, and contract employees table for contract employee. And to achieve that, it's straightforward. All you need to do is decorate the respective types with a table attribute, and that will do the trick. So let's actually go to the sample database, and let's delete the sample database. And then let's go ahead and decorate the employee class with table attribute. So table, and this table attribute is present in a different namespace, system.component model.data annotations.schema. So let's bring in that namespace, and then specify the parameter, which is nothing but the name of the table. So we want to map this employee entity to employees table. So it's as simple as that. Similarly, we go to contract employee entity, and then here we specify we want to map this to contract employees table, and again we need to resolve the namespace. Similarly, let's do it for permanent employee as well. So table attribute, and then we want the table to be permanent employees, and let's resolve this namespace. Alright, so with these changes, let's run this webform1.aspx. So it's still refreshing, so it's creating the sample database and the required tables for us. So now let's flip to SQL Server Management Studio, refresh. We have the sample database, and if you look at the tables, look at, we've got 3 tables. Employee entity information will now be stored in this employees table. Contract employees data will be stored in this contract employees table, and similarly permanent employees data will be stored in permanent employees table. So now let's actually execute this insert script to insert some test data into the respective tables. So now let's actually select the data. So there we go, we have the data. Now let's reload this web form. And when we select all employees, it should load all the employees. Now, to get the first name, last name, gender, annual salary, hourly pay, hours worked, all these column values, obviously Entity Framework has to write a SQL query that's going to join all the 3 tables. Whereas when we load permanent employees behind the scenes, SQL, Entity Framework is going to write a SQL query to join employees and permanent employees table. And when we select this, it should join employees and contract employees table. If you fire up SQL Profiler, you should actually notice the queries that are being generated by the Entity Framework. Now let's make another change here. To this web form, let's add a button. Let's actually add 2 button controls. And here, let's change the text on this button to something like add permanent employee, and similarly let's change the text on this button control to add contract employee. Now let's double click this button, and then here we are going to write some code to add a permanent employee to the database. So let's actually copy and paste this code right here. So notice that here we are populating these first name, last name, gender, and annual salary properties. We are creating an instance of the permanent employee entity, and then we are adding that entity to the employees collection and then calling save changes. Similarly, let's go ahead and generate the event handler for add contract employee, and here let's write some code to add contract employee to the database table. So again, straightforward, we are creating an instance of contract employee class, and then we are adding that instance to the employees collection of employee DB context and then invoking save changes. Now if you look the database at the moment, we have got, look at that, there are 7 rows within employees table, okay, and then 4 rows within permanent employees table and 3 rows within contract employees table. Now let's run this and then let's add the permanent employee. So now when we add permanent employee, look at that, it's loading, meaning it's adding permanent employee to the database table behind the scenes. So once that is done, when we execute these queries, look at that, within employees table, the employee ID, first name, last name, and gender property values are stored, and within the permanent employees table, the data that is specific to permanent employee is stored. So here annual salary is stored. Okay, now at the moment contract employees table has got only 3 rows. Now let's add a contract employee. So that should have been added. Now when we come and execute this query, notice that here within the employees table, now there are 9 rows, and then if you look at contract employees table, we should have 4 rows. Okay, so the data that is specific to contract employee is stored in this table, whereas ID, first name, last name, gender are stored in the employees table. So Entity Framework behind the scenes is going to write the required queries to store the data into the respective underlying tables, and we have just seen that in action. And another way to actually map the entities to different tables is by using Fluent API, and we have been using this in the past videos in this video series. So simply by overriding on model creating method, what we can do is, instead of using this table attribute within employee DB context class, we can actually override on model creating method, and then here we can say model builder dot entity of employee entity. So we want this entity to be mapped to table employees. Okay, similarly we want to map permanent employee to permanent employees table and contract employee to contract employees table. Now if we are using the Fluent API, then again there's no need to use this here, so we can comment that out. And then let's quickly delete this sample database. And when we run this web form 1, it should still create 3 databases. Now we are using Fluent API to map the classes to respective tables. So it's still loading there. Now let's go ahead, refresh this. Notice that we have those 3 tables created. So at this time we are using Fluent API instead of that table attribute, just by overriding on model creating method. Alright, that's it for today. Thank you for listening. Have a great day.